I'm Zijing Zhang, and I'm also from University College London about the School of System Construction. Today I'm going to talk about our research on using machine learning for automated detection of ambiguity in building requirements. So as Alex mentioned, this is also in the context of automated compliance checking, and Nick maybe didn't give you like an overview of this topic, so I'm just help you to familiarize this topic again if you are not familiar with it. So for automated compliance checking, it's defined as a piece of software that assesses the design. It could be in any kind of format, such as a building information model or like just paper-based drawings. And this kind of design model is checked against a set of rules, constraints, conditions, requirements, and you get a set of results such as pass, fail, warning, and also Nick just stressed on the importance of the unknown, where the needed data is incomplete or missing in the design model. And you can also have a look at the graph which shows the process. And we can see that there are multiple actors involved in this process, and it's in general quite complex, and there are a lot of knowledge exchanges in this process. So this topic is not new. It has been researched by researchers and practitioners for almost 50 years. As I've just mentioned, there are a lot of actors, and there have been two approaching perspectives. One is the target model perspective, which is about the design model, and it's shown on the orange cycle here on the graph. It's about having the building design and then maybe make some modification to it. The yellow cycle here is the rule perspective, which concerns the interpretation, the representation of the building rules in a machine-readable way, and there might be some coding involved here or not. And the green cycle is just the introduction of the regulation, the implementation of them. So my research, my PhD research is focused on the rule perspective. And specifically, during my research, I found that, well, there have been a lot of research on this topic and almost 50 years of all of the publications. But there's a challenge about interpreting and representing ambiguous requirements. Also, as reported by Soliman, Junior et al. In 2021, 53% of building requirements cannot be checked automatically through ACC, primarily due to ambiguity. So before jumping to the actual research of ambiguity, let me just give you a definition of ambiguity to distinguish maybe from other terms such as subjectivity. So ambiguity occurs when a statement has more than one meaning. And what do we mean here is that it could be the words within the statement that has multiple meanings, or maybe the sentence structures have multiple meanings. For example, for the case of words, the word bank can mean the financial establishment where you take your money out or have your personal savings. For the second meaning, it could be the piece of land alongside the river or the lake. For the sentence structures, this sentence, well, there's tall men and women. It can be a case of both the men and women are tall, or maybe we're only talking about the men are tall and the women are not tall in this case. So there are like multiple meanings in this case. And that's the general example, but in the context of building requirements, the first example is waiting areas should be close to the clinical or work area served and the WC facilities. And the close to here is ambiguous because there are multiple interpretations of it, and we can say 2 meters is close to or not close to. Secondly, the main entrance and reception areas should be pleasant and welcoming. And it's also the case that pleasant and welcoming can be related to maybe the furniture or maybe the color of the wall. So there are also multiple meanings that are possible here. And the third example is additional space may be required for a special bath, and we're not sure how much space is needed additionally, and what are the types of special baths. And actually, there are different types of ambiguity as well, but I will not go into detail about these different types of ambiguity, as this research just focuses on detecting ambiguity in general. But if you are interested in the different types of ambiguity, we have just published a paper on the taxonomy of ambiguity in building requirements. So coming back to the main objectives of this research, we want to understand ambiguity in building requirements better by having a little bit of literature review, and also propose a method to detect ambiguity in building requirements automatically. So firstly, we look at ambiguity in different domains, so not just within the ACC or the AEC industry, but also beyond that. So firstly, we found that there's limited research about ambiguity in building requirements. Therefore, focusing on the classification of ambiguity, such as artificial and natural ambiguity, where artificial is the use of language that the requirement can be written better to maybe be unambiguous, and natural ambiguity maybe is more difficult to deal with. And then there are also some solutions proposed, such as spatial artifacts. And also we reviewed ambiguity in linguistics, legal studies, and software requirement engineering, and found some interesting results, including the different types of ambiguity in linguistics, legal studies, and also specifically in requirement engineering, there are some kind of domain-specific ambiguity that could also exist in the ACC domain as well. We also reviewed some methods to detect sort of ambiguity or doing text classification of contracts or building requirements in general. There's no research focused on detecting ambiguity in building requirements, but there's a similar study on vagueness detection in the Fiddick Silver book, the contract. And also in the existing studies, the documents are mostly classified based on their contents or scope. But for the ambiguity, the issue is more complex, as it might be related to the words or the sentence structure. And also different types of methods have been proposed, such as rule-based machine learning or hybrid approaches. So for our work, we did the initial exploration in this area by using a supervised machine learning model. And we collected data from health building nodes in England, and they're known to have some ambiguous clauses, and we labeled them as T or F for each clause, where T means ambiguous and F means unambiguous. And importantly, we took the whole clauses, not just the sentences, such as the clause 4.25 here. And we also did some data pre-processing, train test split, and then we represent them using different types of text representation, and using a single algorithm, a simple vector machine. And did some 5-fold cross validation, and they were evaluated using 3 metrics: accuracy, precision, and recall. And here are just the formulas for calculating this. And just a note here that although we had 3 metrics, but we are really prioritizing recall score because not omitting single ambiguous sentence is more critical than ensuring every ambiguous sentence detected is actually ambiguous, and it's also more important than ensuring all the predictions are correct. Because we only use one algorithm, and also the data set is relatively small, so this is the performance generated. It still looks promising. In terms of the findings, we find the model based on the TF-IDF feature weighting method has the best accuracy score. And the increase of the n-grams is not helpful, and the unigraph model had the best accuracy results among the n-grams. The highest mean precision was achieved by the model based on the TF-IDF representation, followed by the unigraph model. And we really care about the recall score, and we got the highest one on the model based on trigrams. And then, in general, this shows a satisfactory performance and the potential of using supervised machine learning methods to detect ambiguity. In conclusion, we propose the supervised machine learning model to automatically detect ambiguous requirements. And we found they have potential, and of course there are some limitations, including we can use more data to improve the model performance. And also other machine learning models, algorithms, and the pre-processing process and other feature selection methods can be used to improve the performance. And we are also currently trying rule-based and hybrid methods to further improve the performance. And we also hope that with the knowledge of different types of ambiguity, and we can further improve the performance as well. So this is just about my research, and if you're interested in knowing more about ambiguity in compliance checking in general, as part of my PhD, I'm doing a focus group on ambiguity in building requirements. So if you want to know more, you're very welcome to participate in the focus group. And please get in touch if you're interested in knowing more about that. Thank you very much.